So the requirements are, number one, it needs to be a simple random sample. And number two, the populations are normally distributed. And by that, it's a strict, they definitely have to be normally distributed, otherwise this is going to okay, so we'll talk a little bit about that later. So what I'd like to do is go ahead, open up your worksheet 11.4 in Canvas. Okay, so while you guys are opening that up, I'll just read this. Okay, worksheet 11.4. Investor believes that Cisco stock is more volatile than General Electric. Here are a simple random sample of 10 months of Cisco, 14 months of GE. Is there evidence of this at alpha equals 0.05? So notice right off the bat, your population, your sample sizes do not have to be the same size for this test. Okay? So we got 10 months here, we got 14 months here. Okay? So the first question that you should ask yourself is qualitative, quantitative, or regression? Yeah, quantitative. Do you like to say categorical better? Categorical. Okay, it's the same thing. Categorical, quantitative, or regression? Quantitative, right? You got a bunch of real numbers there, right? Okay. All right, so it's quantitative. Next question is, what's the null and the alternative hypothesis? Okay. So, Taylor, must be your turn. What's the only alternative hypothesis on this one? Is it too small?
I just pull it up. So I don't know what symbol
Okay, let's talk about what does volatility mean? When the investor believes it's more volatile, what do you think that refers to? Less stable, what does that refer to? Ups and downs, what statistical term does that apply to? Standard deviation, right? We're talking about standard deviation, right? So Taylor, if we're talking about standard deviation, what do you think I should use? What symbol? And what's the symbol for standard deviation? What is that? Sigma. So sigma 0.05? So you're saying the standard deviation is 0.05? I think your phone and friends people are going like this. Coy, you know. No? Oh man, if we get this wrong, it's going to be a tough test. Chris? Sigma 1 equals sigma 2, right? Or maybe a more, so that's perfectly fine. If I wanted to be very specific, I might say sigma of Cisco equals sigma of GE, just so that I'm more clear. But yeah, sigma 1, sigma 2, that's fine. Okay? I think this is probably a little bit more clear though, right? Okay, so what should the alternative be? N2 must be returned. We're picking on the back row today. Okay. Now the investor believes it's more volatile.
Oh,
That's your clue, right?
Yeah, so
And rather than use 1 and 2, I'm going to say sigma of Cisco what? Greater than? Greater than sigma of G. Okay? Does that make sense? Okay?
Yeah.
What'd you say?
So more volatile means it's
Bigger
going to
standard
be
deviation.
greater standard deviation.
Okay, what's the next question you're supposed to ask yourself?
What type of test is it?
Type of test. Okay, and the options are
Z,
P,
T,
Z,
chi-squared,
chi-square,
F,
or F, right? What do you guys think?
chi-squared.
Okay, so chi-squared is a really good guess, but we're dealing with two standard deviations,
Test.
so it's in half. So, just so you know, the F is a chi-squared divided by a chi-squared. And oh, by the way, chi-squareds aren't symmetric, so what do you think about F's?
Boo.
They're not symmetric either.
Why is that?
So we get to bring in a new distribution. Aren't you glad this one's not on your test?
Yes.
Good thing to stop at 11.3, huh?
Yeah.
Okay? All right, so let's talk about characteristics. Oh, and by the way, this isn't actually the formula. That's the theory behind it. The F distribution is going to be S1 squared divided by S2 squared, which is nice and simple, except for, because it's a we've got two chi-squares, that means I'm going to have the degrees of freedom of the numerator equals n1 minus 1, and the degrees of freedom of the denominator equals n2 minus 1. So we get two sets of degrees of freedom, not just one. That's going to be fun, right? Maybe I should just show you this really quick before I get into that. Now, here, I'll do this first. The characteristics of the F distribution. Okay? Number one, as we mentioned, it's not symmetric. And it is skewed right. Okay? Number two, your degrees of freedom depends, no. Your shape depends on your degrees of freedom. Okay? Number three, I'll bet you can get the total area. What do you think that should equal? 1. And number four, F is always positive. Why do you think it's always positive? It's a chi-square divided by a chi-square, right? Okay? All right. So, let's look at the chi-square for a minute here, or excuse me, the F. Okay, so these are various things. So this is the degrees of freedom in the numerator is 1, degrees of freedom in the denominator is 1, that's the red line, it looks like that. Okay? Degrees of freedom in the numerator is 2, degrees of freedom in the denominator is 1, it starts here, it's, ooh, didn't mean to click on that. And that's the black line. Okay? The black line starting at 1 here. Okay? Degrees of freedom in the numerator of 5, degrees of freedom in the denominator is 2. That's the blue line, which starts down here at 0. The green line is 10 degrees of freedom in the numerator, 1 degree of freedom in the denominator. And if we go 100 and 100, that's the gray line. So you can see that this one changes pretty dramatically. Okay? So, yeah, that's going to be an interesting one. Now, let's talk about how to find the critical values for a right tail test with alpha equal to 0.05, degrees of freedom for the numerator equals 10, and degrees of freedom for the denominator equals So if you look in the back of your book, you've got a table, I think it starts on page, that's not the right table. Here it is. I think it's on page A15 in the blue section at the back of your book. Okay, so here's how you're gonna read this. Now notice, look at the picture first. It's a skewed right distribution. It's telling you the area to the right, okay? So across the top, I've got the degrees of freedom of the numerator. Down the side, I've got the degrees of freedom of the denominator, okay? Now, let's go here. In my case, I've got an alpha of 0.05. Ignore that for a second. Degrees of freedom in the numerator is 10. So I come across here, it's not even on the first page. Gotta go to the second page, okay? 10 degrees of freedom in your numerator. 7 degrees of freedom in your denominator, so 7's down here. So this intersects here. Now, in this area here, I'm looking for my alpha is 0.05, so 10, so I'm right here. I get the value 3.64. Does that make sense? Okay.
Okay.
Now, what if it asks you for 11 degrees of freedom? This table's kind of worthless. Okay? So probably I'm going to be, I'll probably quiz you on this, but most of this stuff's going to be on the computer. Okay? I want you to be able to do this at least one time. Doubt I'll test you on it, but I'll quiz you on it tomorrow. Okay? Now let's do another one here. What if I said find critical values for two-tailed test. Alpha equals 0.05, degrees of freedom equals, for the numerator, sorry, let's specify, numerator equals 15 degrees of freedom for the denominator equals 20. Now, as we think about this only tells me what's to the right. Okay, if I'm doing a two-tailed test, I'm going to need to know what's to the left. Okay, so here's your rule for area to the left. Okay, so f of 1 minus alpha with your degrees of freedom for your numerator and your degrees of freedom for your denominator equals 1 over f of alpha, denominator, numerator. So notice I flip those around. Okay? Let's do the one first that's going to be easy. Okay? Two-tailed test. Okay? Degrees of freedom is 15. So I'm in this column here. Degrees of freedom of the denominator is 20. I'm not on the right page. 15 and 20. So I'm in this section here. Okay. If it's a two-tailed test with alpha of 0.05, what's my alpha over 2?
0.025.
0.025. Okay, so I'm going to be looking at the 0.025. 15, 20, 0.025. I get a value of 2.57. Okay, so if I'm going to draw this picture, okay, from the F distribution skewed right, this value is 2.57 on the right side. Okay, that area there is 0.025. Now I'm going to figure out this area here. I want that area to also be 0.025. Okay, then I'm going to use this formula right here. Okay. So what I'm going to do is I'm going to flip these around. So now I want my numerator to be 20 and I want my denominator to be 15. So my numerator is now 20. My denominator is 15. I'm still at 0.025. That gives me the value of 2.76. You see that? Now what I do is I take 1 divided by 2.76. Okay, so in this case, I get a value of 1 divided by 2.76, which equals 0.362. It's gonna be a fun test. Aren't you glad I didn't put this on the test?
Yeah. I don't get it.
Okay? Does that make sense?
So that 0.362, that's 1 over 2.76.
Correct.
Where
Good
did the
question.
2.57 come from? I get.
How did we get the 2.57?
Yeah, is that just?
So you use these just as they are,
Oh,
15
okay.
and 20,
Oh, and then you switch
and
them.
then you switch
put
them for the
over
other one. You switch them and you make it a reciprocal.
Oh, okay, okay.
So that's your upper and that's your lower.
Yeah, this is my upper,
Yeah.
this is my lower.
Oh, okay, okay,
Okay?
okay.
So wait, f of 1 minus alpha?
See, it could have been worse.
So f of 1 minus alpha, but we did alpha over 2.
Well, it's a two-tailed test, so you get your alpha over 2.
Alpha over
So my alpha over 2 is this, and then 1 minus that.
2. And then 1 minus.
Don't get too hung up, just do what I did, okay?
I'm trying to figure out what you said.
Okay, so, okay, in this case, my alpha is 0.025, this is 0.975. Does that help? You've got 97.5 to the right.
Okay.
So you still use your alpha, so 0.025, and then you just swap those two. That's all you do. Okay? Let's go on the guard and the level. Let me do that. It's not even part of this problem, so this is practice. Okay? All right, so type of test, this is the F test. I'm gonna say that F equals, according to this nice little equation, isn't this nice?
Yeah.
Okay, S1 squared divided by S2 squared. So I need to find out my standard deviation, right? Equals the standard deviation of, really I'm finding my variance, but this will work. So, and then this one equals the standard deviation of that. Okay, so as we look at these two numbers, does it appear that Cisco stock is more volatile than GE?
Yes.
Okay, 11 to 4, it looks like it's a lot more volatile, right? Okay, now by the way, notice it's getting negative returns and positive returns, which, you know, that's what you'd expect from a volatile stock. Okay, all right, the question is that a significant difference? Okay, so in this case, I found my F statistic, so let's pick on Cooper. What do I do next?
Let's see. So you take the standard deviation of. You don't have the standard deviation.
No, I do.
Right. So you take 11.8
1.8,
and then divide it by
no, I'm gonna square up first.
and then divide it by
Divided by 4.21 squared. So I got an F value of 7.51, okay? Now I'm gonna do this both the classical way and the p-value way, even though, okay? So if I'm doing this the classical way, I'll erase that, okay? So I got a value of 7.51 here, right? Okay? So am I doing it the classical way or the p-value way? What do you want me to do? The p-value way. So if I'm doing it the p-value way, I got 7.51 here. I'm trying to figure out that area. That area is my p-value, right? Okay. Now, as we look at my chart, we probably should figure out my degrees of freedom, right? Degrees of freedom for the numerator and degrees of freedom for the denominator. Okay. What's the degrees of freedom of the numerator? Katie, it must be your turn.
Which one, how do you know which one to do? Out of the Cisco and G?
Of the Cisco, yeah.
Would it be Cisco?
Yeah,
The
Cisco.
first one?
Okay. So your degrees of freedom for
10?
Cisco is 9.
Oh, 9?
We've got 10 months of stock, so there's 10 of those, right? So 10 minus 1 is 9. And your degrees of freedom of your denominator
13.
is going to be 13.
Oh, they're right there.
14 minus 1 is 13. You can count them just to make sure. Sometimes I don't count very well. Did that time. Count as good as Nate Silver. Okay? All right. So now, what? Now we can look this up on our chart, right? Some of you like the classical method. So if I'm doing this with the classical method, I'm going to erase this. Okay, the classical method says I'm doing a one-tailed test, right? I need to figure out what that value is. Okay? So I look it up on my chart. See, I got 9 and 13. Look it up on my chart. 9 and 13. What's the problem?
There is no 13.
There is no 13. This is a worthless chart.
Yeah, sucks.
It's not worthless. I'm going to make you do one of them that's actually on the chart, but I can't even do it with this problem. Okay? Just for fun, let's say that it was 12. 9 and 12, my alpha is 0.05, right? 9 and 12, I would get 9 and 12, 0.05, I would get 2.80, right? Does that make sense?
Mm-hmm.
So just for sake of argument, even though this is the wrong number, because my chart's not good enough, you know, I got a value of what?
2.
Oh, I have, yeah, so I got 7.51. So where am I? I'm out here in the tail, right? What does this tell me? This tells me reject. But, once again, that number is not right. Okay? So I got a computer. I could actually find out that, well, let's see. Let's find the p-value.
F distribution, right.
F dot dist, right? Do I want a right tail or a left tail?
Right tail.
Right tail test. Can you do a two-tailed test?
Yeah.
Not on F.
Oh, it's
Okay? Because, why not?
not symmetrical.
Not symmetric. Okay? What do I put in for my X?
Your F score.
My F score, 7.51. Degrees of freedom of the numerator,
9.
9. Degrees of freedom of the denominator, 13.
Boom.
What does that give me?
Rejection.
That also says reject. Right? Okay, so Taylor, conclusion is,
there is not enough evidence to support that Cisco.
There is evidence.
Oh, there is evidence to support that Cisco's
Evidence
stock is
that
more violent than General Electric.
Cisco is more volatile than GE. Okay? Now the one thing that I would just mention here, okay, I don't think I've told you this before, but unless you're doing any genetics test, if your p-value is less than 0.01, we would not only say it was significant, we would say highly significant evidence. So as we look at this, think about this. Cisco's 3 times more volatile than Cisco, right, than GE, right? That seems like a lot, right? Even if you didn't do any statistics, doesn't that seem like a lot?
Mm-hmm.
Yeah. He was up too late watching the election, I can tell. Okay? All right. So, highly significant. Now, just for fun, I got a computer, right? Do you think it can tell me what this true value should be?
Yeah.
What do you think the command should be? F dot inverse, right? And we're going to do a right tail test. What's the probability? What should I put in there? 0.05. I'm putting my alpha, right? 0.05. Degrees of freedom, 9 and 13. Okay?
So the inverse is where.
So rather than 2.80, I should have gotten 2.71, which isn't too far off. But that's what it should be, 2.71. Okay? Does that make sense? sense.
Right, so when you're using like inverse in your function, so like you're using the inverse, does that, so like if you're doing a right tail test, that means that you're trying to find the left side, so when you do inverse.
Well, you're trying to find whatever this,
So, like-
whatever that is. So yeah, if I'm doing a right tail test, I want 5%, I want my alpha in this case there.
But if you're
And
trying
it
to
will
find the
tell me
left
where
side.
that line is.
Okay.
So that's gonna divide the 5% from the 95%.
So would you call that your critical value?
So that's your critical value, yes, critical value, that's exactly what that is. That's your decision point. You get an F value greater than 2.71, you're gonna reject. You get a value less than 2.71, you are gonna not reject. Okay? Make sense?
And we use the highly significant if it's less than 0.01?
Yeah, generally if it's less than 0.01, you would say highly significant. You might even get to use the A word. Okay? All right. I guess we talked about the election more than gonna let you guys go in more in the election.
Can you post it?
You want me to post that?
Please.
Yeah. That's a good question. I didn't bring my book. I was so flustered about the election, I forgot about it. Do we have a confidence interval? I don't think we do that with for standard deviation. See if there's a formula there. I don't have it in my notes and didn't bring my book, so I don't think we do that. This is a good one. See if there's a confidence interval for standard deviation. Should be in the, it should be in your card. Basically, look at your card. Well, this is, oh, you don't have a card?
Yeah, it's just like attached.
Yeah, it's not on the card. So, I won't make you do that. Okay? Anything else?
And on the test, we
Okay.
don't have to find the sample size if it doesn't give us that formula.
It's not on there, no, I won't make you do that. Just the QQ. I'm actually not gonna make you do the QQ. Okay, but you should remember for the final, because that sounds like a good thing. Okay?
How do you tell when it's highly significant?
Less than 0.01. Your p-value is less than 0.01. Okay? All right, anybody not pick up their quizzes? Oh, did I pass those out? Oh, I forgot. Yeah, let's pass those out really quick. I'll let you guys go, get your quiz, and then